Okay, so you sent us something pretty interesting this time. It's all about system design.
Yeah,
And this whole idea that it's like the key, like the golden ticket to reaching those like really high salaries in tech.
absolutely.
So for this deep dive, I think our mission is pretty clear.
Yeah.
We got to figure out why this article is saying system design is so important, especially if, you're thinking about some serious jumps in what you make.
Yeah, I think this is something that a lot of people in tech kind of struggle with. Like, what really sets apart those who see huge growth in their salary compared to others who, at least on paper, have really solid technical skills? And that's exactly what this article's trying to dig into.
Totally. And it's like, this article, it almost feels like it was written for someone just like you.
Right.
Right. I mean, someone who's put in tons of time, tons of effort into mastering DSA, data structures, and algorithms.
Right.
They've cracked those tough LeetCode problems, solved like 500 plus. They've built this incredibly strong foundation.
Yeah.
And they're probably thinking, okay, I've got this base, so what's going to launch me to that next level?
Absolutely. And the really cool thing here, what the article really highlights, is this question. If everyone kind of needs a good grasp of DSA to even get in the door, then why are there such big differences in salaries? Why are some people making, say, 50 LPA while others are, maybe in that 15, 20 LPA range? The article's argument is that there's something else, another layer of expertise that's really setting those higher earners apart.
And that layer, according to this piece, is system design. It's like, as you start aiming for those more senior roles, the interview process changes. It's not so much about those basic coding puzzles anymore, like, okay, quickly reverse a linked list under pressure.
Yeah, and if you think about it, that makes sense when you consider what those senior roles actually involve. Companies hiring for these positions, they're not just looking for someone who can code well. They need people who can think strategically, architect those complex systems, make sure they can scale. And that's really what system design is all about. It's that process of defining the whole architecture, the components, the modules, how everything interacts, and how the data flows, all to meet those specific requirements. And it's not just about making it work. You got to consider scalability, how reliable it is, the cost, all that stuff. They need someone who can see how all those pieces fit together in a real-world application, and often those applications are massive.
Right, exactly.
Yeah.
And to really drive that point home, the article gives some super concrete examples. Like, imagine having to design a URL shortener, but not just any URL shortener, one that can handle 1 billion requests every single day.
Wow.
That immediately throws a whole bunch of new challenges at you, way beyond just whipping up a simple algorithm.
Exactly. 1 billion requests a day that forces you to think about how to spread that load across multiple servers, how to make sure generating those short links is super fast, and of course, avoid any conflicts or duplicates. You start thinking about things like load balancing, different types of databases, all sorts of stuff.
Yeah.
And the other example in the article, designing a payment system that basically never fails, that really shows how crucial system design is in certain areas. It goes way beyond just, basic functionality. You have to build in robustness, resilience, especially at scale, and of course, make sure those financial transactions are always secure and accurate.
Totally. And here's where the article gets really interesting. It starts asking some pretty thought-provoking questions, almost like it's throwing them right at you. Like, how much of mastering system design is about that pure theoretical knowledge, the kind you get from books, diagrams, online courses, and how much of it comes from practical experience, actually building and running these systems out in the real world?
Right, because that raises the question of how you even learn system design. Can you prepare for it in the same kind of structured way a lot of people do with DSA, where they practice a bunch of specific problem sets? Or is it something that you kind of pick up more organically by dealing with the real-world messiness of large systems and seeing how they can break down?
And that's a really important thing to consider, right? I mean, you're putting in the time, putting in the effort to learn and grow.
Yeah.
So knowing whether you could just study your way to becoming a system design expert, the same way you might grind through those LeetCode problems, that's valuable information. It helps you figure out where to focus your energy, where to invest your time, if you really want to see that big career jump.
Absolutely. So what this article seems to be saying is that having a deep understanding of system design is like this essential ingredient if you want to see a significant boost in your salary, especially in tech. And while having a good grasp of DSA, data structures, and algorithms is definitely a must, it's that ability to think at a system level, to design and scale complex solutions, that really seems to separate those top earners from the rest. This emphasis on system design just shows how the whole industry is shifting towards building and maintaining these really complex, super large-scale systems that are distributed all over the place. And in that kind of environment, a bad architectural decision can have huge, really expensive consequences.
Okay, so just to recap here, the big takeaway, the main point the article is making, is that if you're looking for that major step up in your tech career, a big jump in your salary, then mastering system design seems to be absolutely crucial. It's not enough to just be really good at those foundational DSA skills.
Right.
You got to show that you can think strategically, that you can solve problems at a much bigger architectural level.
Exactly. And that leads to a really important question for you to think about after reading this article. It talks about this balance between having the theoretical understanding of system design and having that hands-on experience. So how do you see yourself navigating that balance as you learn and grow? How can you go about getting both that foundational knowledge and the practical exposure you need to really excel in this field, which is obviously complex, but also super valuable, because ultimately that's what's going to drive your career forward.
And that is a great question to ponder.
Yeah.
Until next time.
See ya.